Why isn't IEnumerable consumed ? How do generators work in C# compared to Python? So I thought I understood C# yield return as being largely the same as Python's yield, which I thought that I understood. I thought that the compiler transforms a function into an object with a pointer to where execution should be resumed, and when a request for the next value comes along, the object runs up to the next yield where it updates the pointer of where to resume execution and returns a value. In Python this works sort of similarly to lazy evaluation in that it produces values as needed, but once the values are used once they can be xed if not saved in another variable. Trying to iterate over the result of such a function twice returns an empty iterable unless you transform it to a list. X. Outputs. Until recently I thought the same thing was true for C#, but trying it out in .NET Fiddle failed. This URL. Outputs. What is happening here? Is it caching the result? It can't be right, otherwise file.read lines would blow up on huge files. Is it simply restarting the function from the top a second time? Note, I'm a bit uncertain about some of the terminology of generators and coroutines, so I've tried to avoid labeling.
You're very close. An IEnumerable is an object capable of creating an iterator, an IEnumerator. An IEnumerator behaves exactly as you've described. So the IEnumerable generates generators. Unless you go out of your way to generate some sort of state shared between the generated iterators, IEnumerator objects won't affect each other, whether they are from separate calls to the iterator block or another IEnumerator generated by the same IEnumerable.
After looking through every part of the code, I believe it has to do with IEnumerable. If we look at MSDN, IEnumerable is not a numerator in itself, but it creates an enumerator every time getEnumerator is called. If we look at getEnumerator, we see that for each, and IMagineString.join, calls getEnumerator, creating a new state every time it is called. As an example, here's the code again using an enumerator. .NET Fiddle. When move next reaches the end, it has the behavior of Python as expected.
The reason the code behaves differently in each case is because in Python, you are using the same IEnumerator instance twice, but the second time it had already been enumerated, it cannot repeat it, so it does not. However, in C#, each call to getEnumerator returns a new IEnumerator, which will reiterate through the collection from the beginning. Each enumerator instance does not affect other enumerators. Enumerators do not implicitly lock the collection, so the two enumerators can both loop through the entire collection. However, your Python example only uses one enumerator, so without a reset, it can only iterate. The yield operator is a utility for returning IEnumerable or IEnumerator instances more easily. It implements the interface, adding an element to the returned iterator with each call to yield return. With each call to y, a new enumerable is constructed, but each enumerable can have more than one enumerator. Each call to string.join calls getEnumerator internally, which creates a new enumerator for each call. Therefore, with each call to string.join, you loop through the entire collection from start to finish.
When the compiler sees the yield keyword, it will implement a state machine in a nested private class inside the program class. This nested class will implement IEnumerator. Before C# had the yield keyword, we needed to do this ourselves. This is a slightly simplified and more readable version. The y method will change too. It will simply return an instance of this nested class. Notice that nothing happens at this point. You are only getting an instance of this class. Only when you start enumerating, with the for-each loop, the moveNext method on the instance will be called. This will yield the items one at a time. This is important to realize. The for-each loop is also syntactic sugar. It actually calls getEnumerator. If you call is.getEnumerator, you can even see that it has a method moveNext and a property current, just like an IEnumerator should. If your main method had a line like and you would step through it with the debugger, you would see the debugger jumping back and forth between the main and y methods. It is normally impossible to go in and out of a method like this, but because in reality it is actually a class, this works. Because string.join simply enumerates the whole thing, your example would not show this. Now, every time you call, another for-each loop is called, so another enumerator is created. This is possible because the inner class also implements IEnumerable. They just thought of everything when they implemented the yield keyword, so there's a lot of compiler magic going on. One line with a yield return turns into an entire class.